I just realized I make a mistake in my work for number 56. It's actually that it was technically correct, but then I didn't get what I wanted because I make a mistake actually at very early stage. You see, like if you compare to my work there, my r prime t, I wrote 1 negative 1 2t. It's supposed to be t. Supposed to be t. Okay, that's my mistake. And then I carry my mistake correctly, but because of that extra 2 there, I didn't get what I expected. Well, anyway, so my magnitude of r prime t, you know, that is 1 over square root of 2 plus t squared. So my unit tangent factor will be 1 negative 1 t divided by that, right? Okay, and then my t prime t, of course you have a couple ways to do that, to do this, right? Okay, but I have a tendency to do this method phi f phi, the derivative of this equals to f prime factor v plus f times the derivative of factor v. That's what I have, that's my tendency. Okay, but that's, of course, that's not the only way to do it. And this will then be negative 2t over 2 plus t squared to the power of 3 half times that factor plus 1 over 2 plus t squared to the power of 1 half times 0, 0, 1, which with, if I put things together with LCD, 2 plus t squared to the power of 3 halves, then in the first term, I will have the 2 cancels, right? So I will get negative t times 1 negative 1 t. And the second term will be 2 plus t squared to the times 0, 0, 1. Now that will simplify to be negative t, positive t, negative t squared plus 2 plus t squared. On the denominator, I have 2 plus t squared to the power of 3 halves. This is basically negative t, t2 over 2 plus t squared to the power of 3 halves, such that the unit normal factor will be, notice that this is just the coefficients, right? So I can ignore that. Then my unit normal factor will be negative t, t2 over square root of 2t squared plus 4. Notice that I can factor the square root of 2 out. 1 over square root of 2 plus times 1 over square root of t squared plus 2 times negative t, t2. Now, why do I do that? Like what you have seen before, that my binormal unit binormal factor, which is the cross product of unit tangent factor by unit normal factor, that is the ijk. I will write the coefficient of unit tangent factors outside, and I put this inside, right? Okay, and then the unit normal factor, I write the common factor, the scalar, outside, and this is negative t, t2. You will see in the outside I have 1 over square root of 2 of t squared plus 2, and the cross product will be negative 2 minus negative 2 minus t squared, right? And then negative 2 minus t squared, comma 0, right? And notice that I can factor that negative 2 minus t squared out, and it will cancel with the denominator, while inside the factor I have 1, 1, 0. Notice that it is actually it's a constant factor. Okay, it's a constant factor, which implies the binomial factor, which is always perpendicular, right, is it's constant and it is on the same plane, as long as we can show that the osculating plane which is normal to the binomial factor, which is a constant here, must be given by x plus y plus equals to constant d. Okay, and we did this in my original. So my original work, the one that I have to correct, actually starts from there. Okay, and the outcome becomes quite strange. But the nice thing is, like, my b unit binomial factor happens to be parallel to the same factor 110. Okay, so you will see this is t plus 2 plus 1 minus t equals to d. That gives me the same d. Okay, so the osculating plane is given by x plus y equals to d. And notice that this curve is always on this plane. This curve is always on this plane. Okay, do I still have that? Yeah, well, the graph you can see is the same to the one I did in my original work. Okay, this is the correction.